Good afternoon, everyone, and welcome to the second session of I Can't Wait to Get Back to the Office, Creating a Workplace to Love. This morning's session with Nigel Osland gave us some real areas of focus, prompting us to take a more human-centered approach to decisions around how we use space, moving away from that traditional cost-based model and challenging us to stop looking to increase density, but to utilize space in a more productive way. I must say, I also now understand the terms sociofugal and sociopetal in a much more clear way than I ever thought I would do. And that to really understand how to use space, that we really need to spend quality studying time in the pub. I'm sure this afternoon's session, looking at the new ISO standard on open plan offices, will be equally interesting and thought-provoking as Jack Harvie-Clark takes us through the new standard and how it can be used to influence the design of open plan spaces. Just a quick reminder before we start, all the sessions that we're doing are being recorded and will be available on the event site into the future. So if you missed anything or you want to go back and review and listen again, please feel free to do so. They're there for you to use again. With that, I'll hand over to Paige Hodsman, who will take us through opening this afternoon's session. Over to you, Paige.
Thank you, Jonathan. Hello, everyone. And for those of you who are just joining us for the afternoon session, I'm your host for these live presentations. My name's Paige Hodsman. I'm the concept developer for Workplace for the UK and Ireland for Ecophon. And with the exception of tomorrow's afternoon session, I will be hosting the presentations, and then my lovely colleague, Andrea Harmon, will host the final session tomorrow in the afternoon. Just a note on the questions, you'll have an opportunity to post your questions in the chat box during the presentation, and then we'll answer those at the end during the Q&A. And I understand you have to scroll down to the bottom in order to post your questions. I'm so pleased that our next speaker has agreed to be here with us today. Jack is the founder of Apex Acoustics, whose new acoustic design method for open plan offices received 2 awards in 2019, and the appeal method for evaluating the acoustic conditions in open plan mixed use spaces received an innovation award in 2020. He sat on the International Standards Committee for this ISO 22955, the acoustic quality of open office spaces, and he's going to take us through this new groundbreaking standard. Jack, welcome.
Thank you very much for that introduction, Paige. Yes, my name's Jack Harvie-Clark from Apex Acoustics, and we've been designing open plan offices for over 10 years and publishing our own research into acoustics in open plan offices for more than 5 years. So I was part of the committee that wrote this standard. So it gives me great pleasure to have the opportunity to take you through it today. How can ISO 22955 help you create a workplace to love? This is the first international standard that takes open plan office acoustics outside the box. By outside the box, I mean it's not just about the room acoustics, because people's experience of acoustics or noise in offices is not just about the way the room responds to sounds. This standard offers some tools that can help all stakeholders in offices. It's a standard for clients, project managers, designers, facilities managers, and occupants. To get the best out of your offices, there's something in here for everyone, and every one of those different groups of people has a vital contribution to make if you're going to achieve an acoustically successful workplace. I'm first going to talk about the diverse range of tools within this standard before going into the detail and the implications for the process of curating acoustic success. Let's remember that a standard is a measure of something. So how do we measure the things that correlate with the outcomes that we want to achieve? We want a workplace to love, of course. So what are the determinants of acoustic satisfaction in open plan offices? As soon as you ask that question, you realize that there isn't going to be a single answer for everyone or for all offices. It's going to depend on so many factors: the particular people, the range of activities undertaken by any one person at different times or different people, the acoustic environment that they're operating in, the extent of choice and control, so their relationship with the organisation. It's a mixture of so many different types of factors even. So where do we start? This standard fills a gap between the emerging evidence in the science and what looks like good practice. The central part of the standard is about achieving particular values for parameters that I'll describe. In standard speak, this is the normative part of the standard. So if you want to claim that you've complied with the standard, you have to do these things. But there is also a lot of guidance that you can use, if you wish, in the informative parts of the standard. This doesn't affect formal compliance with the standard, but I think some of the most useful information is in these informative parts, and these are the parts that really take the acoustics outside the box. So clients can simply refer to this standard or the specification of the office. And by specification, I don't mean the performance of the ceiling or the screens. I mean this describes the performance of the space for the particular activities that are taking place in it. So that's very easy. It's very shorthand and easy for clients to do. But clients also have a much greater role, I think, in determining acoustic satisfaction that I'll explain as I go through this. Then there's the planning, or the acoustic space planning, if you like. Traditionally, this was done. This is done by the interior designer or the architect, or somebody, as Nigel said, cutting and pasting rows of desks onto plans, deciding on the layout. So there hasn't formally been any formal tools for the acoustic space planning, but that's an intrinsic part of this new standard, is a tool for doing this. And as Paige mentioned, this was one of our contributions to the standard that we won an award for a couple of years ago. And then there's the detailed design. So this is what people often think of when they think of the acoustic design of the offices, the specification for the ceilings or screens or walls and doors, the bits and pieces like that. There's information for the operation, because I would say the acoustic design doesn't finish when you've finished with the plans. As people start using the office, they have to negotiate that. So the office is a tool for the organisation to achieve its functional and operational requirements. So how people work out how to use it is an evolving process. So there are vital tools in this standard that help occupants and facility managers improve the acoustic conditions in the office. So this is a part which is not normally considered as part of the acoustic design at all. So why did we need a new standard for acoustics in open plan offices? And I'll come at this question from two different ways. So Leesman have very kindly been collecting and publishing information on occupant experience in offices for a long time. They've been saying for a long time that workplaces are failing organisations, which also mean they're failing the people who have to use them. And one of the biggest problems has always been noise. And there's not a lot of detail of this in the Leesman survey, but the levels of satisfaction with noise generally are extremely low, even for high-performing workplaces. So what is this noise problem? And in that context, I'd urge you to listen to Dr. Peggy Roth tomorrow, who's going to be saying what we found from the great home working experiment that's been going on and how much more effective many people's homes are for enabling productive work compared to workplaces, and what we can learn from that. I think in terms of what I'm going to say, that will become clear too. So there's lots of research that shows that the main problem with noise is unwanted speech. When we hear unwanted speech, it's very difficult not to hear it. So we evolved our hearing system as an early warning system. It's to keep us safe. So sounds that are moving or new or changing grab our attention very strongly. If we hear speech, it's very difficult to ignore it. And if we can understand it, the processing of understanding it interferes with our own internal conversation. So it's distracting and then very annoying. There are other problems that come up with noise as well, such as telephones ringing, noise from equipment such as printers or air conditioning, people passing by, or even a particular colleague. So the noise problem is diverse, but the most significant aspect of it is usually unwanted speech. If we look at the output from the acoustics community over recent years, there was a focus on this problem of unwanted speech. How can we derive acoustic parameters that describe an open plan office's response to intelligible speech? So before this standard was invented, we had parameters for reverberation time that you might have heard of. So it's how quickly sound in a space decays, but it doesn't tell us how intelligible speech is at any particular distance from someone talking. So back to that question about how do we have measures that correlate with the things that we're interested in? And in this case, the outcome is the intelligibility of speech. So this standard, just published in 2012, introduced 3 new parameters. The first one is the spatial decay of speech, D2S. So this describes how quickly speech reduces in volume with distance as you move away from the person talking. And the next one is a bit of a mouthful. I call it the speech level at 4 meters, LPAS4M. So this tells you how loud speech is at 4 meters. So you need to know both these things, both how loud speech is at 4 meters and how quickly the speech level is decaying with distance, to know how loud a speech signal is at any particular distance. Then in this standard, there's another parameter called the distraction distance, or the radius of distraction, RD, distraction distance. So this describes the distance at which the intelligibility falls below a level such that speech starts to become less distracting. If you can't understand the speech, it's less distracting to you. So speech in a foreign language that you don't understand is much less distracting than speech in a language that you do understand. How can we use these? So this standard proposed these measures, these indicators, but at that time there certainly wasn't enough experience of anyone to suggest what values might constitute good acoustics or bad acoustics in an open plan office. So they weren't correlated with the outcomes that we're actually interested in. So there was some guidance about those numbers in this standard, but there wasn't anything concrete, if you like. They were in the informative part of the standard. So the vision for this standard then. So in the meantime, several countries such as Finland, Germany and France have all developed their own national standards for acoustic conditions in open plan offices that pick and choose from the parameters in that ISO standard for different reasons. This particular standard, ISO 22955, was proposed by the French and based on the French national standard. So one of the first aspirations was to identify target values for those indicators. So what are good acoustic conditions in open plan offices in terms of these values? As I mentioned, it was based on the French standard, which they spent about 5 years developing. And this in itself was a fairly big paradigm shift from previous approaches to open plan office acoustics, because it introduced this idea that actually the activity that people are doing is core to the acoustic conditions they need and the level of acoustic control they need. So it takes an occupant-centered view of the conditions for people. And within that context, what are the acoustic conditions that people need? It was also, the French standard has been very successful as by being a guide for both acousticians and other stakeholders. So I mentioned that list of people and I said they all have a vital role. As I go through this talk, I'll explain and show you the evidence for why the role of all the people involved in the office have got a vital role for its acoustic success. So the core of this new standard then is based around activity in different space types. And the main activities are classified as a contact center, which is where the activity is mostly telecommunication with someone outside the office. Contact center, sometimes called a call center. Offices for collaborative work, where the main activity is communication with the nearest colleagues, and individual work, where most of the activity is individual, is not collaborating. So these are the three core areas, but there's 6 space types altogether, and the other ones are one, receiving the public, because shops and banks where there's counters are places, they're also, workplaces for the people who work there. So what are the acoustic conditions that they need? I won't go into detail about that, it's probably of less interest to you here. There's a space type which is described as combining activities. So this is an extension that wasn't in the French standard at all. It's an entirely new section. So how do we design for combining different types of activities on one floor plate? Because in reality, floor plates rarely, unless they are contact centers, have only one type of activity over the whole floor plate. And there's a space type as where the activity is unknown, a vacant floor plate, where the information is in an annex. So let's look at the detail then of how the standard treats these different places. So this is the first table for a contact center. And there are 3 types of indications indicated in the standard. So these are at the workstation, between workstations, and across the floor plate. And for these interactions, the acoustic challenges and description of the criteria are identified, and there's either target values or required values. So the target values aren't necessary to be achieved to claim compliance with the standard, but they're in there to help the occupants, as I'll explain. So for this one, for a contact center, you can see the acoustic challenges and how they're described. And there's a target value of a noise level in use of 55 dB. So this is to limit the overall noise exposure of people, as you can see. So between workstations, the challenge is reducing distraction to your nearest colleagues. And for this, there's a required value, this new parameter that was loosely described in the French standard, and we've improved the description and definition of that here. So a DAS, which is an in situ attenuation of speech of greater than 6 dB. Practically, what this number means is that you need if people are seated, you need a screen of at least 1.3 meters height between people, between adjacent desks. And that's without any reflections from the soffit or walls or other things like that. So it's got significant design implications straight away. These numbers, and none of these numbers are innocent. Now across the floor plate, you can see the challenges and the description there. And there's required values for, so reverberation time. We had a lot of debate about whether that should still be in this standard, because it's not really a relevant parameter for open plan offices at all. It doesn't really tell you anything about the acoustic response of the space. And it's debatable whether you can actually even measure it consistently. You have to have special rules for measuring it in open plan offices, because it depends how you measure it. So we're going to ignore that. That's what I'd call legacy criteria in there. Underneath there, there's the spatial decay of sound, spatial decay of speech greater than or equal to 7 meters, and the speech level at 4 meters, less than or equal to 47 dB. So I will explain what those mean very shortly and what the implications of those are. So let's look at the other main space types. So collaborative work. At the workstation, the challenges are described like this, and there's a slightly lower target value for ambient noise. Between workstations, it looks like this. So this time there's a limit on the attenuation between workstations, because obviously you don't want to stop people having easy conversations between each other. So this number actually means that screens have to be less than 400 mil above the desk height, effectively, so that people can talk easily to each other with good intelligibility. and then across the floor plate. So we've got the same reverberation time criteria. We've got slightly different numbers for D2S and LPAS4M. So I'll collect all these together at the end and explain what they mean. For individual work, and this is probably the most challenging condition, I'd say, to design for acoustically, because this is where the problems occur. This is where the noise problem manifests most significantly, interfering with people's individual productive work. So we know what the challenges are. There's a target value for a lower level of ambient noise in there. We've got the same attenuation between workstations as we had for a call center. And actually across the floor plate, we've got the same criteria again as we had for a call center to limit the adverse effects of speech, prevent buildup of noise. So let's bring all these numbers together. So the target values are in here. So as mentioned, these are for the benefit of the occupants or the facilities manager so that they can measure noise levels in an office. They've got something to compare what they measure with. Is what they measure any good or bad? So these are suggested values. Later on. But that's what this information is for. The required values, the in-situ attenuation of speech. So where it's greater than 6 dB, as I've already mentioned, that implies a screen of 1.3 meters, a minimum, above floor level for seated people between workstations in those types of offices. There is reverberation time, which is, if you're going to meet any of the other criteria, you're certainly going to meet that one. So then there's the spatial decay of speech and speech level at 4 meters, which look like this. So the numbers in the end up very similar. So 1 dB between these things is on the limit. I mean, it's probably around about the just noticeable difference and the smallest amount that you can, I'm not sure if you can actually even reliably measure differences of that small. So they're all effectively in the same, all in the same space. And that's because this is, as you need as much acoustic protection as possible in any of these types of offices, really. What do these imply for the detailed design of the office? This mock-up experiment, this is just a schematic, if you like. Think of this, don't think of this as an office design, an experiment to test what will be achieved if you had 1.5 meter high screens between your rows of desks and a Class A ceiling. And this is in a relatively small room. And it's more difficult in a small room to achieve good values of these parameters because the sound doesn't have so far to go, if you like, more concentrated. So this gets a spatial decay of sound of 6 dB. So it doesn't meet any of the space types. And the speech level at 4 meters was 48 dB. So it just meets the criteria for a collaborative workspace, but not the spatial decay of sound one. If you introduce screens that are 2 meters high between these desks, then you get a spatial decay of sound of 7 dB. So this is just meeting the criteria for a call center or individual working. And in this case, the speech level at 4 meters has been reduced to 45 dB. So you've well and truly solved that problem, if you like. What this means is that an open plan office needs to be not very open. There needs to be significant screening and significant amounts of sound absorption if you're going to achieve these values for spatial decay of sound and speech level at 4 meters. So is this necessary? Where's the evidence that shows that we really need to do this to get good acoustic conditions? So fortunately, the people who were behind the original standard which defined the indicators, who came from the Finnish Institute of Occupational Health, published all their, well, a large body of their research. So collected over 15 years that correlated the parameters they talked about with their survey data, their questionnaires, which identified how disturbed people were by noise. So this has got people highly distracted. Sorry, on the x-axis, RD is the radius of distraction. And on the y-axis, you've got percentage of people who are highly disturbed by noise. And I think the first thing that I notice in this is a lot of scatter, and they've plotted a line through it. And you can see the R squared there is 0.29. So not a very good correlation. I think it's the first thing I think. They conclude distraction distance predicts perceived disturbance by noise because there is some correlation. Obviously, there's lots of other factors. What this shows is that affect acoustic satisfaction or being highly disturbed by noise. It's not just, so this was the best effort to produce room acoustic parameters that would correlate with the problem of unwanted speech, but it still doesn't predict very well, I would say, people who are highly disturbed by noise. And they give some clues in this immediately themselves. So these 4 points, which are with triangles, these are offices in which they either have activity-based working or there is a quiet, protected area to where people can go and be protected from noise. So these don't seem to follow the pattern of the rest of the data necessarily at all. Also in this data, there's some offices where they'd done the measurements before any interventions were made, and some offices where it was following a change. And depending how the change is managed from cellular to open plan, many people anticipate problems in an open plan office if they're coming from a cellular office environment. So they're going to have a problem because they're going to anticipate a problem, depending on how that process is managed, of course. If we were going to design for 20% of people being dissatisfied by noise, which is quite a common approach, we'd be looking to design to a radius of distraction of about 3 meters. So I think the first thing to note, there's only one data point, only one office in that quadrant of the graph. And what a radius of distraction of 3 meters implies is not only significant screening, as I described in the previous slide, but also a high level of background noise. So this parameter, to achieve control of distraction, in this parameter, you can use masking sound. And I'll talk much more about that later because it's highly controversial. But is it necessary to design to this value to get good acoustic satisfaction? Well, there's about 5 offices in this survey which have less than or around about 20% dissatisfaction by noise, with values of up to maybe 13 dB for the radius of distraction. So first of all, it's very difficult to design to a value of 3 and doesn't look like it's necessary. Let's look at a bit more data that's correlating the acoustics of the room acoustic response, and people's responses, how many people are highly disturbed by noise. So from this study, we can look at the correlation with the other parameters. First of all, we can look at the speech level at 4 meters. So this is in the same format with the parameter on the bottom and highly disturbed by noise up the side. So you can see a slightly lower level of correlation, and it just looks like a lot of scatter. I'm not sure it would have been obvious to draw a line through those points at all if you weren't a mathematician. Spatial decay of sound, actually the correlation is 0 officially for this. Background noise in the office, when there's no one in it, we actually get a slightly higher correlation with people who are disturbed by sound. So some of those offices, those 2 offices on the right hand side there, those 2 triangles, they've almost certainly got masking sound systems in to limit the distraction of noise, but they're also activity based or have a quiet area. So we can't necessarily tell what it was that enabled those people to be have better acoustic satisfaction. So just last year, some people in Germany added their data to this data set. So this is now presented the other way around. So they've got the parameter on the on the y-axis, and here it's the D2S, the spatial decay of speech, and people who are highly disturbed going across on the x-axis. They've still got 0 correlation with this parameter, D2S. But they find slightly better correlation with the speech level at 4 meters by adding their data in. And they suggest that designing to 20% dissatisfaction, and you come up with a number of 47 dB as the limit for speech level at 4 meters. So this was published after we wrote that number in the standard. So that's quite reassuring that they're coming to the same conclusion that we did in the committee. because there's very mixed data for all these things. So if you design to 47 dB speech level at 4 meters, will it give you good levels of acoustic satisfaction? Not necessarily. There's offices in there with 60% of people being highly disturbed by noise, even though it's achieving less than 47 dB. Well, it still doesn't seem like it's sufficient, but it's the best bet. It's definitely not enough by itself. And this is why I say we need to think outside the box. The room acoustics itself doesn't answer the question of how you design for acoustic satisfaction in a workplace that you're going to love. The acoustic space planning is something that I mentioned earlier on. And there's lots of different types of evidence to suggest that this is one of the most important factors for achieving acoustic satisfaction. Because if you think about those room acoustic parameters, they don't take any account of what people are doing or what the adjacencies are. So you might put people who are running a help desk next to people who are trying to do mostly quiet individual work. And that's obviously going to cause a problem. But that wouldn't be picked up with any of those room acoustic parameters because they're just describing how the sound travels across the room in general. So I mentioned there haven't been previously been any formal tools for the acoustic space planning. So I think we can think about what we're interested in like this. So how much acoustic separation do we need from an area that might be for recreation? Someone's having a cup of tea on one side of this screen, and the other side is, or two people, sorry, having a cup of tea, having a chat about non-work things. And on the other side, two people are having a one-to-one in a workplace setting. So I think if you can hearing people talk about non-work things is typically more annoying than people talking about work things. So how much acoustic separation do we need between those particular uses, or between that recreational area and the desks for focused work? Or between the open plan desking and a focused booth, or between the two sides of a focus booth itself. Or if that focus booth is used for a long telephone conversation, is that going to impact on people at the open plan desks? How can we understand the acoustic separation we need between all these different types of uses, for example, between the meeting room area and the open plan desks? So this was one of our contributions to the standard, was to think, well, actually what we need is a matrix between different types of spaces. So we can characterize spaces with increasing sound emission, or from which sound is increasingly annoying. And we can think about spaces that are increasingly sensitive to sound going across here. So in this method, we're characterizing the source and the receiver and using that information in the context of the background sound in the office to evaluate what type of signal to noise ratio, might be appropriate to achieve between those two uses. So we can think of signal to noise ratio, or we can think of speech transmission index if we're doing it by modeling. So rather than just targeting 0.5, we might be targeting lower values where we want better levels of privacy or discretion. So the process is described in our previous conference papers. In this table, this is the table from the standard, and it says potential DAS ratings. And I urge you to, and at some places it says this is an example. Sometimes in a standard, when it says this is an example of a table of numbers, it means that because we don't really have evidence for this, but this is our expert opinion on what we think is good. I definitely don't think these are the right numbers, because one of the most significant things that affects how much protection you need from one place to another is how much control people have over where they sit. So if you have assigned desks, people need a greater level of acoustic protection because they've no other recourse for their environmental satisfaction. If people do have control over where they sit, you need a completely different level of acoustic control. So it depends on the context very significantly. We've populated this table with numbers and given the basis on which they're there for this in situ attenuation of speech parameter. So these are unfamiliar numbers because we're not used to thinking about the attenuation within an open plan area from one space to another. The definition is given in the standard. And if we go back to this layout, which looks maybe a bit crazy, different types of spaces, and whether these numbers are achievable. So it does look like from the modelling that significant values for this parameter are achievable in an open plan space. So there is a method for doing some acoustic space planning. You obviously need to do it in the context of the open plan design because it depends on the acoustics of the ceiling and everything else about the room. So the space planning and the detailed acoustic design really go hand in hand. But this type of method is best used REBA stage 2 or 3. And you're thinking about the layout and adjacencies between different types of uses. The additional tools, there's 7 annexes, 2 of which are normative and 5 of which are informative. And I said at the beginning, I think some of the most important tools are maybe actually in these annexes for the overall achievement of acoustic satisfaction. So there's guidance on the calculation of the in situ attenuation of speech. There's process flowcharts. So these are the normative annexes. The process flowcharts take you through the process, whether it's a new office or a retrofit project, and identify which different parts of the standard you should refer to at different times, and what are the optional tools that you could use at different times as well. There's 3 annexes on tools for the occupants or in use. There's one on measuring noise in use, because that's not described in any other standards. How do you measure noise, characterize noise in an open plan office? There's an annex on the collective use etiquette that I'll talk a bit more about. One on an acoustic comfort survey, which I'll talk a bit more about as well. And there are the criteria for a vacant floor plate or where the activity isn't known. And there's one on sound masking systems, which I'll talk a bit more about too. So these tools for users, the collective use of open plan spaces. So this is something that is most effective when it's developed by the users for themselves. So this is having a forum for people to agree how they should use the office. People often aren't aware of what it is about their behavior or their acoustic emissions, if you like, the sounds they make that might really annoy other people. I think it's very difficult to be sensitive to other people's levels of acoustic tolerance. If you think some people need to go to a busy cafe, noisy cafe, to be able to do focused work, they need that sense of environment. Other people couldn't imagine doing that, and they need it to be quiet to be able to concentrate. So we have a very diverse range of acoustic sensitivities between us. And I think it's very difficult for us in general to understand someone else's perspective in terms of acoustic sensitivity, even before we start talking about neurodiversity and all the rest of it. So in this annex, there's a suggested range of points that might be useful to people to consider. So these are pointers if people get stuck, if you like. But the most important things are as the people adopt these themselves for their own use, so that people agree the rules between themselves. It's described as an example of a user survey. So this is based on a previous French project. So there was a lot of research that went into this. And this noise comfort, or effect of noise on comfort in open plan offices questionnaire it looks a bit clunky in the annex because the way you write it all down on paper, you get these questions and boxes with little things. But if you actually turn it into a questionnaire, it kind of looks more sensible. So we found this to be very useful. So it's always answered anonymously because noise is a very political issue. And this can be very useful for finding out what the issues are, because people don't always complain about noise issues because they don't want to make a complaint about it. They don't want to complain about a colleague or the fact that they maybe find something difficult that other people don't necessarily seem to find difficult. So this questionnaire allows you to benchmark the general acoustic sensitivity of people in your offices and identify what are the most problematic noise levels. So this information can feed into the user etiquette, if you like, as well, is one way of using it. Another way of using it is to find out what would be the most significant interventions to improve people's acoustic satisfaction without touching the fabric of the building. And then there are the criteria for a unknown or vacant floor plate. These are fairly similar to things that are in the BCO guide, things like that. So this is making sure the base build of the office will be suitable for the fit out when it comes. Masking systems then, and why is it so controversial? So to people in some parts of the world, a sound masking system is essential in any new build office. They can't imagine building an office without one. In other parts of the world, they've tried them and found them completely intolerable. They've turned them off, thrown them away. They would never contemplate using them again. Why these big cultural differences towards this technology? This was a very nice survey which looked at sound masking and the trade-off between the masking effect and user acceptance, because the purpose of masking sound is to make speech that you would otherwise be able to hear less intelligible. So I would certainly distinguish it entirely from soundscaping, if you like, what's sometimes called soundscaping, or adding biophilic sounds to an environment that might enhance the environment in some way. So I'm thinking about sound masking as something which will be more like a blanket, if you like, and make sounds that would otherwise be more intelligible, less intelligible. So obviously in that context, the louder it's going to be, the more effective it is. But the louder it is, the more annoying it is. So is there a level that you can play anonymous sound at that has an impact, but which is still acceptable? I think to some extent that's the crux of the question about whether it's essential or intolerable. And certainly in America, they expect their building services to be louder. They have higher criteria for building services noise, for example. They accept building services noise more readily, and they would never build an office without sound masking. In continental Europe, they're completely the opposite. Offices are much quieter, and they find it very difficult to imagine, and their experience of trying to introduce masking sound, they find it very unacceptable. In this country, I think we're somewhere in the middle. I think there are situations where it can definitely help in offices, and there's certainly other situations in which people often don't like the idea of being blasted by white noise, which comes back to this notion of control again. And in this survey, people's favorite type of masking sound was their own music. That's what people want to listen to, and they like the idea of technical noise the least. But control was one of the most important things for people. And so I think one of the ideas about masking sound that I think is the least acceptable is this idea that you're subject to it somehow, that it's imposed on you. So the way in which a sound masking system is introduced into an existing office, I think is probably very important for its acceptance by the users, as well as things about, can you perceive where the sound is coming from, or do you notice any patterns in the sound? Those things are crucial to making it acceptable to people. But I think it's a technology which maybe has a place, but it's sensitive to all sorts of details in it. So on this question of control then, we don't consider this in acoustics so often at the minute, but it's well established in other aspects of building services as a killer variable. So this is a paper from about 20 years ago that identified control as one of the most significant factors affecting comfort, and comfort being very closely correlated with productivity. If people aren't comfortable, they rarely feel that they can be productive. So in the context of thermal comfort, the idea that control is important, for example, is intrinsic and well established. But we don't often think about this in acoustics, despite the fact that the word noise is sometimes described as sound that the recipient doesn't want to hear. So the lack of control is implied in the word. But we don't usually start our acoustic assessments with how much control do people have over these noises. This approach has been highlighted, and I keep going back to this report by Nigel Osland and Paige Hodsman from over 5 years ago and keep learning new things from it. And they identify noise as control there as one of the recourses to improve acoustic satisfaction in open plan offices. And this more recent paper took a soundscape approach to the problem, and their conclusion from looking at all the different aspects and the interventions, if you like, for acoustic design, they concluded that the two most important factors for occupant satisfaction, acoustic satisfaction, were control and the acoustic space planning. A little preview of a paper that I'm publishing tomorrow, presenting tomorrow in Stockholm, a case study of an office where they had a transformational project. So they had the traditional layout was rows and rows of desks perpendicular to the window. So that industrialized working environment that we're all familiar with. And they said, hey, we need to get away from that and do something better. And they experimented and experimented. And it was design-led. They didn't have an acoustician on board. And as they went, they kept doing lots of staff surveys, user surveys on this new floor plate to find out how people found it. They kept talking to them and adjusting it and so on. So in this new design, they didn't change the ceiling. They didn't change the lighting. They didn't change the heating, ventilation, air conditioning. So the other aspects of the physical environment, they knew they hadn't changed, but they're continually measuring the staff satisfaction with these aspects. And they came to us and they said, oh, you know, can you measure the acoustics on this new design so that we can describe it and make sure that other places that use this design achieve these acoustic conditions. So we benchmarked the new design layout against the old traditional layout, and we couldn't detect any difference between measuring spatial decay of sound, speech level at 4 meters in the empty office, or even the occupied acoustic conditions, which we measured as well, a few different parameters, but we couldn't detect any significant differences. So to a certain extent, so what people had on this new floor plate was new ways of working. They could just find a place to work that suited them. So what they were given was complete control over their environment, and they could work from home too. So this is an example of the increase in satisfaction that people can get without changing the physical environment at all. So there's satisfaction with the lighting, there's satisfaction with the thermal environment, and here's satisfaction with the acoustics. We can benchmark these values against the global Leesman index, and you can see the lighting and the thermal comfort were exactly on the global averages. And then they've significantly increased just by giving people control. The acoustics was already well above the global average, and I don't yet have an explanation for that. And even if we put the Leesman Plus global score on, so these are the highest performing workplaces in the world, the acoustic satisfaction achieved here it far exceeds the average score for the Leesman Plus workplaces. So I think this is a great perspective of how important control is for acoustic satisfaction. To conclude then, so you can see I've gone a little bit beyond my brief, and I haven't just described to you what's in the standard, but how I think you can use it and what's important. I hope you can see that in the standard, there's information that will hopefully improve understanding and expectations about the outcomes. Remember about what we measure and how is it going to correlate with the outcomes. So measuring the building acoustics or the room acoustics parameters is not going to correlate very well with the acoustic outcome in terms of how many people are highly disturbed by noise. It's only one aspect, and I think these much softer aspects are also important, and this, by having these other tools in this standard, this draws everybody's attention to them. So noise is a technical subject, technical subject, but it's a human problem, and many of the solutions are human rather than technical. So with that, it offers the opportunity to improve acoustic conditions for people in open plan offices, and it offers new methods to help achieve these too. And with those clear design goals. Now, how do we create an acoustic workplace to love? think we know the answer to this, really. We need to find out what people need, first of all, and we need to survey everyone, not just a small sample of people, or not ask management what they think people need, because two different people doing the same job with the same activities will have different acoustic needs. We need to find out what everybody needs and design the right sort of spaces, plan the right sort of spaces for them. So if we start with preconceptions about what an open plan office might look like, then we're going to make the same mistakes that we've already been making. So we need to take people's responses seriously and design those spaces. So this is one of those areas of that office that achieve very high levels of acoustic satisfaction. Looks more like a cafe maybe, or a pub, which, as Nigel mentioned, have been so successful in creating different open plan spaces. The important things I think about achieving acoustic satisfaction are about giving people control. So this is not just about where they work and how they work, but also within an office, give people control over the acoustic environment by giving them a forum to address acoustic problems rather than having to avoid them. So they're all different forms of control. Do acoustic space planning carefully. Give it enough attention. And then finally, the room acoustic design. As I've said, those two go hand in hand, really. But to me, I think the smaller part of achieving acoustic satisfaction is what people traditionally think of as the acoustic design of the office. If you've designed your office, the layout and everything, and then you ask for, can you do some acoustic design on this, as we often get asked, most of the decisions that will affect the acoustic outcomes have already been made. But the briefing, to a certain extent, which is the most important, I think, as Nigel mentioned this morning as well, in achieving a workplace to love. It's how that workplace is conceived and its purpose and what the scope is for that design. And this is another view of that workplace that achieved very high acoustic satisfaction and was all done without an acoustician. Thank you very much.
Oh, thank you, Jack. That was brilliant. I don't mean to embarrass you, but you have such a nice way of explaining a complicated subject to make it easier for us, definitely to make it easier for us to understand. And I've read the standard, and I still appreciate this run through. Okay, so I've got a question for you. In this standard, we see the acoustic descriptor workstation noise level, which is measured with normal activity in the room. So for example, with the office equipment and a human presence. And you did mention that this isn't typical. So for standards we've seen in the past, this just wasn't done, which it may have even been maybe a criticism in the past. But can you talk us through how this is done?
Yes. Yeah. So I referred to those numbers, the target values in the standard for the noise level in use, that I think as designers, we would often think, oh, well, we can't design for that. But somebody can design for that. I mean, you think you can design a library that's quiet. How do people know to be quiet in there? You can design a cafe that's noisy. So who is responsible for that design? And it's definitely not just about the fabric of the room in terms of achieving those noise levels. But traditionally, acoustic design has focused on the empty room, the criteria for the empty room. It hasn't addressed in-use conditions. So this is the first attempt to address in-use conditions, if you like, in a standard like this. And if you think about an international standard, that requires international consensus, which is quite a high bar. So so by its nature, it's relatively conservative. To go back to that question or that thought about what you measure and how it's correlated with outcomes. So not the actual noise level in offices is not that well correlated with outcomes. So there was some Dutch acousticians at M&P who proposed a new indicator that they call liveliness for characterizing the sound in open plan offices. And this takes account of both the sound level and the fluctuation strength. As I mentioned earlier, fluctuating sounds attract our attention a lot more than stationary or constant sounds. And so they're more distracting and more annoying. And speech naturally contains a lot of fluctuation in it. So they measured they used an indicator based on another indicator that other people have developed to combine these two factors, both the noise level and the level of fluctuation, to describe liveliness on a 10-point scale that's correlated with people's perception of liveliness. So this would, to some extent, be, and we've used this, and it's a very useful thing for explaining whether office is calm, tranquil, lively, or turbulent, because people understand that immediately. They need decibels and things to convey what those words mean. But that would be a bit edgy, if you like, for an international standard. It doesn't have international acceptance. So we've gone for, the dBA level. So the ambient level is the level in this standard, and it's measured for at least 4 hours at a workstation, at a position that a person would normally occupy. So it's the noise level that somebody would be subjected to. So it's a bit like a noise at work measurement, if you like. Okay. But without the noise from the person who would be there.
Well, it's at least a step in the right direction, isn't it?
Absolutely, yeah, absolutely. Yeah.
Okay, so we have another question here. This is about soundscaping. And do you see a role for this? And like sound masking, is there any cultural differences in its acceptance?
That's a very big question.
Yes, it is.
Very important question. Was there any differences in its cultural acceptance? Sorry, was that? In the soundscaping. So I don't know.
Oh, sorry, I was going to say, I think you mentioned also that with sound masking. So, for example, the United States and on the continent, for example, there's very vastly different views on sound masking systems. But have you seen anything to show that there would be a similar difference in acceptance on soundscaping?
Yeah, no, I haven't. Is the easy answer to that.
Okay.
So that's so I think that's. So that's more the not experimental, but more advanced end, if you like. When you start thinking about having more biophilic elements in your office, do you include sound as well as visual clues for natural influences? And I definitely haven't seen information about cultural responses, if you like, to those types of things. I know people often start with strong ideas about whether they think sounds should be acceptable or not, and they don't always get the results that they from surveys that they would like to achieve, because there's so many confounding factors, as I mentioned before, in the way in which these things are introduced and how much control people have, what they were used to, that it's very difficult to tease out what it was that caused the result that was found.
And also then, it's that subjectivity, isn't it, too? Right, so we're just getting to the end now. I'm going to have to cut off our questions, but what we'll do is we'll take any details, and if it's all right, email you with those questions to follow up with, if that's okay.
Absolutely.
Okay, great.
I'm sorry I didn't leave enough time for more questions, but thank you very much.
No, it's okay. That's okay. So I just do have one more question to end this. So let's say we've read the standard, we get the gist, but we're still not quite sure of how to apply it practically. What do we do with it? I mean, what in terms of the specification and design? What's your advice?
Well, I think that's a very leading question. Thank you for that. So although this is a standard for everybody, for clients, project managers, designers, and occupants, you might find it useful to have an acoustician on board who can support your vision of the processes you want to go through.
Yes.
And the extent to which you want to consider acoustic satisfaction, and the compromises that you might make to the acoustics for the other aspects of the design. Because we don't prioritize traditionally we haven't prioritized the acoustics at all, but we don't want to prioritize it above other things that are also important to come out of the design. So it's making those decisions knowingly, isn't it, rather than in ignorance about the impact they're going to have. So find someone who can support you on the journey you want to go with.
Fantastic. Thank you. Thank you so much, Jack.
Thank you.
Good. So everyone, join us here tomorrow at 10:30 a.m. to hear Peggy Roth from Leesman talk us through the latest Leesman data with figures and insights about the future of workplace. In the meantime, feel free to peruse the rooms off the lobby. There's a lot of content, including the new guidance document for conference rooms, for audio and video capabilities. Jack, I think you were part of that one as well. And there's a lot of expertise that went into this document, so please take an opportunity to pick up a copy. Have a lovely evening, everyone, and we'll see you tomorrow. Thank you. Bye-bye.